Okay, let's look at one more type of problem where we have two equations and two unknowns. So I'm giving some information, but I don't have enough to solve it the way I've been doing it before. So I have horizontal displacement. I have a launch angle. That's all I know. So my data is horizontal displacement is 250 meters. I have an acceleration of 9.81 meters per second squared, and it acts down. I have an angle of 50 degrees. First thing I would probably want to do is draw a picture. So there's the ground. So there is my path. This angle for launching is equal to this angle for landing as long as my launch and landing heights are on the ground. My maximum height occurs when I've gone half my trip. So the time to get to the maximum height is half of my total time for travel. Those two pieces of information are useful to know. So what do? I would suggest first thing you always want to do is write out your equations. In general, you want to write out your equations for both horizontal displacement and vertical displacement. Write out the equations and then start putting in numbers and see what turns up. So for horizontal, I have delta x equals my velocity in the x direction times time. Well, I don't know my velocity in the x direction. I don't know my initial velocity, but I do know the angle. So I can put in some information. My horizontal displacement is equal to my initial velocity times the cosine of my angle times time. And I can even put in a number for my horizontal displacement. I have 250 meters equals my initial velocity times the cosine of 50 degrees times t. All right, so I've got two things that I don't know. I don't know my initial velocity. I don't know time. Let's take a look at my vertical information. So delta y, okay, we're going to have acceleration because we're moving vertically, so 1/2 times g times t squared plus my initial velocity in the vertical direction times time. All right, can we put any numbers here? Well, we know g because acceleration due to gravity. Change in vertical position. Well, I start here and I end here, so my vertical change in position is 0. Well, that's handy. So 1/2 9.81 t squared. If we make up positive, then this is going to be negative 9.81 plus initial velocity in the vertical direction. Okay, I don't know what it is, but I can do the same thing I did for my horizontal component. So I can take initial velocity times the sine of 50 degrees times t. All right, so let's reorganize and simplify this right-hand vertical equation a little bit. Let's take this and move it to the left side. So I have a positive now, 4.905 t squared equals VI times the sine of 50 degrees times t. All right, we'll have the same unknowns in both equations. Thus, two equations, two unknowns. Let's reorganize one of the equations so that both of our unknowns are on one side of the equals and our known values are on the other side. Doesn't matter which I do. Just for kicks, we're going to move our horizontal equation around. So I have 250 over cosine of 50 equals VI times t. I'm going to take this now and I'm going to put it in my other equation. So now I have 4.905 t squared equals, I'm going to reorganize this a little bit, so I have the sine of 50 degrees times what I'm substituting in, so I have 250 over the cosine of 50 degrees. So now I have all my knowns on the right side and I have only one unknown, t. So I can solve for one unknown. I can find what t is, 7.9 seconds. Okay, what am I supposed to be finding here? I'm supposed to find the initial velocity. Once I have time, now I can go back to either of my equations, either the horizontal component equation or the vertical component equation, plug in t and solve for initial velocity. I'm going to go back to my horizontal equation just because it's simpler. So I have 250 meters equals my initial velocity times the cosine of 50 degrees times 7.97 seconds. So I find that my initial velocity for this particular problem is 50 meters per second. And so that's how I would set up and solve a problem where I have two unknowns, but I have a 0 vertical displacement and I know the launch angle. So that walks us through a variety of types of problems, and your problem set should give you practice with those.